Okay, Zoom. From yesterday, I need to copy it into the appropriate places. LDP, this is RNS. So this goes under CIA and LSVPN, OSPF. One second, guys. Done. I'll do another one. That is your class. Say we did active failover, AA, AS, AA, NAPD. I'll upload this as soon as the class is over. No, Rinchin, right after the second class, I was flying to London, so I just got to London today. So I will do it after the classes today. I'll leave it overnight so for it to be done. Let me just check what's wrong with this. How is it not connecting? I'll give you the plan for today, by the way, until it connects up. Okay. All right, the plan today is to do, I'll take a look at Ike V1 on ASA. We'll do Ike V2 site to site on ASA, Ike V2 site to site on ASA. And then we shall take a look at and connect the clientless web VPN on ASA. Once this is done, we'll also take a look at clustering. Actually, I want to do clustering first and get that out of the way. We'll do clustering based on span mode. And we'll take a look at the interface, individual interface node. This is the plan for today. All right. Let's just check if the thing is on. If not, in the meantime, what I'll do is I will do the lecture portion of clustering, span mode, as well as interface config mode. Let me get my pen. Okay. Let's just check. This is up and we'll get started. Okay. While it comes up, let me go ahead and take a look at your clustering. Clustering can be done in two different modes. Span mode, which is the more common way of doing it. The other mode is called the individual, as common to do. Before I get started, I want to make sure everybody has record permissions. Okay. Much of you guys don't, so Ahmed, I gave it to you. Raza, I gave it to you. Everybody have it now? Make sure. Let's take a look at the two modes. The two modes are span mode or the individual interface mode. What is a span mode? Let me bring up Paint. I'll show you two topologies over here. I'll show you a physical topology and a logical topology. The physical topology, in which you have devices connected to the switch. Let's say this is your switch over here. This should connect up. So 565. Okay, now it's connecting. All right, so we can minimize this. So coming back over here, I have this switch over here. Okay, on this switch, I have my routers connected, my firewalls connected. So I have two firewalls over here. Let's put the two firewalls over here. This is my physical topology. I don't know why it's acting up today. These are my two firewalls connected to the switch. So these ports over here, let's say are gig 01 and gig 03. I'll just use those two ports. These two are the ones that I'm going to focus on. This is my physical topology. So physically, they're cabled up like that. Let's put the names over here. So we are say 1, ASA 2, let's say this is gig 01, and this is gig. Actually, rather than drawing the physical, let me just show you the physical. Sorry about that. I just much easier to do it based on that then, rather than spending time on this. I'll show you the logical topology instead. Physical, we know what it looks like. Physical is this one. If you guys remember, what was it here? I had it somewhere. This one. This is my physical layout over here, right? ASA1, ASA2 connected to the firewall. ASA1, ASA2 connected to the two switches, routers connected over here on the same box. Now, logically, what I want to do is I want the two boxes to act as a single box. If you guys remember yesterday when we did the active standby, I had two boxes, two ASAs. In active standby, I had two boxes, only one of them was being used. So this was the active box. This was the standby box. Agreed? So the inside network going towards the outside, which interface would it use? So if I went from inside to outside, it would use ASA1 to go out, correct? This one was not being used at all. This was just used as a standby box. Clear on that? Okay. Then we went to the second way of doing it. What was the second way of doing it? Active with multi-context. Two inside segments. Let's say the outside was a single segment. C1 would connect over here. I'll put C2 over here. I had the ability to make this active for context 1 and this one as the active or context 2. So if that was the case, where would the traffic for the first segment go out from? Right? And for the second one, it would go out this way. Agreed? This was active. Couple limitations. Number one is the number of boxes that I could have in either active or active standby is limited to 2. You could only have 2 boxes over here. Even if I had 3 boxes or 4 boxes in terms of active standby, the failover, 2 boxes at one given time. So if I had 4 firewalls, I would only be able to leverage the capabilities of 2. Active standby or active. That was one limitation. The other limitation was I could only do this type of stuff, which in essence is called load sharing. Where I'm sharing the load of one segment over one box, the other segment over the other box. This might be 100% utilized, whereas this might not be utilized at all. Because it's not load balancing, it's load sharing. More static. This was up to 9.x. In 9.x, they included or introduced a new feature called clustering. And what does this new feature clustering do for us? Clustering allows us the ability to combine the capabilities of multiple boxes into one box. So now I have the ability to make more than one box act as a single box. So I could have potentially 1, 2, 3, 4 physical boxes. These are 4 physical boxes. ASA1, not context. These are actual physical ASAs. Which would combine the capability of the 4 boxes into a single, more powerful box. You would connect up into the inside segment and the outside segment. So the inside segment to go out had 4 options of going out. You would create these 4 boxes as part of the same, what is known as a cluster. So the power of the 4 boxes was combined. Depending on the version that you do, it goes to 8, and they're looking up at 16 now. 16 physical boxes to be part of the same cluster. You guys okay with this so far? So this is your inside network. And this is your outside network. Clear, you guys? Everybody okay with that? But the thing is, when these people from the inside send traffic to the ASA, how would it go to the ASA and where would it go? This is a logical setup. This example that I gave you, this picture that I drew over here, is the logical picture. In reality, what I did was, the inside network is connected to some form of a switch. So physically, there's a switch over here. I would take a port from each one of those firewalls, same port. Let's say it's gig 01. I would take gig 01 from all 4 ports or 4 firewalls and create a port channel over here on the switch. The 4 ASAs, out of the 4 ASAs, one of the ASAs will be the master ASA, the one that you do all your configuration on, the controller. The other ones do have the ability to be the master. It's based on an election criteria. I'll show you how to do that. So one becomes a master, you configure it. You assign a single IP address. So let's say the inside segment over here has an IP address assigned of 10.11.11.0. You would assign the IP address .11 not to ASA 1 or 2 or 3 or 4, but to the entire cluster. When a packet from here comes in, it comes into the switch. Switch will forward the packet to whatever the port channel decides. So port channel does load balancing. It will send one packet here, the second flow here, the third flow to the third ASA, fourth flow to the fourth ASA. Do you get my point? And similarly, on the outside, I would do the same thing. What would I have on the outside? I would not have a connection directly to a device. I would always have a switch over here. Let's say switch 2. Switch 2 in turn connects up to the outside router. On the inside, again, just like I did on switch 1, I would create a port channel. So the traffic would go from whichever port out to the firewall and the return traffic. So the load balancing is taken care of in this type of setup based on what? The port channel. Does that make sense, guys? Everybody okay with this? Now, in order to do this, you need to be aware of certain things that you need to do ahead of time to set this up. The first thing that you do is to set up a relationship between the ASAs themselves so they can talk to each other. They can use this master configuration replication between them. You guys remember we did a similar type of thing yesterday with failover. Do you remember that we set up one link that all the different firewalls talk to each other for the heartbeat and the configuration replication? Remember that? Similarly, when you do a cluster, the first thing that you do is you set up the 2 devices in a cluster based on a cluster link or cluster interface. So when you have the ASAs, you would have the ASAs connect up to each other over the cluster link. This will act as the heartbeat link. This will also act as your, what do you call it, configuration replication link. All right. Besides that, we will also need to set up the port channel over here towards the switch. Does that make sense, guys? So I need to set this cluster link up where these two devices are talking to each other. Plus I need to set up the port channel towards the outside. What I want to accomplish over here is this. I'll draw this out for you guys. Bear with me over here. So I'm going to have an outside network. Oops. This is my outside network over here, which in turn connects up to a router. Let's say router 1 over here. Then I have, from this network, I will have two links. In reality, they go into a switch, but I'm over here combining it as if it's what? On the same network, but there's physically two links going into the switch. All right, this will connect into the two boxes that I'm going to have. I'm going to have two boxes over here. Okay, they will be connected to each other over a cluster link. They will have the same type of setup towards the inside. Okay, they'll have a cluster link over here. These two links will be part of a port channel. You need to understand they're not port channeling into a link, they're going into a switch over there. The switch needs to be set up for port channeling as well. So this is going to be, let's say, ASA1. And this guy over here will be ASA2. And on the inside, you would have the same type of network. This is going to be R2. This is going to be R1. This interface over here, which is on the outside, let's call it gig 0/3. It's going to be gig 0/3 for both sides. What do I mean by both sides? For ASA1 as well as ASA2, it's the same interface that will form the port channel toward the top, and the same one over here. And it has to be the same one because of the way you configure it. I'll show you when you see the configuration, you'll understand why it has to be the same interface. So that's the way I'm going to set it up. Are all the ASAs daisy chained if there are more than 3 ASAs? No, they're all connected to the switch. In terms of the cluster link you're talking about? Yeah, the cluster link will also be going into the switch. Over here, I'm showing it going directly between each other, but in reality, that will also be going into a switch, and all of the ASAs will go into the same VLAN. So for example, over here, I want to use gig 00 as my cluster link. So what I'm going to do is I'm going to put 00, which is ASA1, this port over here, and ASA2 00 in the same VLAN. This is my cluster link VLAN. All right, does that make sense? And then at the same time, I am going to create a port channel over here on this one. Gig 01, this is the inside port channel. Gig 01, this will be one port channel. Gig 03 will be my second port channel. So the these two will be part of one port channel towards the outside, and these two will be the port channel towards the inside. Everybody okay with that? You guys understand that? And also, so for the inside, I'll put this in the same VLAN. This port will be in the same VLAN as the inside, and this port R2, which is on the outside, will be part of this VLAN. Good. Just give me 1 second. It's acting up today. All right, so let's go and start doing this now based on this. Okay, so how do I go about doing it? Let's do by going into the switch and configuring the switch like we did the last time around. So can you see my team viewer? Okay, good. Let's go to switch 1. Show VLAN. Default interface gig 2/0/1 220. So basically I cleaned up the switch configuration. I'll do the same thing on switch 2. Okay, that's good. I'm not complaining. All right, so my switches are clean. On the routers, there's too much config. So what I'll try to do, actually, I didn't save it yesterday. That's a good thing. Otherwise, I would have to, yeah, this one has it. All right, erase. Reload, let it reload, it'll come back up. It says show mode, single, clear configure. all. Show mode. Gone. So both are blank. Okay. So let's go ahead and set the topology up based on the diagram. R2 F00 should be in the VLAN, and I want to do gig 0/3 on the switch as a port channel. All right. Care of in terms of clustering is what? Step 1, configure the switches to do the physical to logical mapping. All right. Switch 1 and switch 2. We'll do VLAN 10 as the inside VLAN. So what do I have on the inside VLAN? I have gig 00101 of ASA1 and ASA2 port channel, and R1 should be in the same VLAN. This is VLAN 10. So let's put that over here. 10.11.11.0 VLAN 10. That's what I want to do over here. So how do I do it? This is R1 F0/0. So let's do that. Where is R1 F0/0? Which is switch 1, port 1. One step at a time. You don't need to rush. Do it slowly and you will be fine. So on switch 1, I need to do what? Interface gig 1/2/0/1 switch port host, switch port access VLAN 10. Taken care of. The next thing I need to do is a port channel. Now, which port channel? On VLAN 10, which is on the inside, it is gig 01 of ASA1 and ASA2. Where is gig 01 of ASA1 and ASA2? Ports 11 and 13 should be in a port channel. On the switch side, I will do the port channeling on the ASA side later on, but I want to take care of the switches first. So how do I do that? Because they're both on switch 1. Is range gig 2/0/11, gig 2/0/13, channel group, pick a number, let's say 10. Port channel should be on the switch as well as on the firewall. Absolutely. Port channel needs to be on both sides, otherwise it won't work. So I'm doing an LACP port channel, which is a required way of doing it. So channel group, let's say 10, mode active. That's LACP. No shut. And then inside that port channel 10, I'll say switch port mode access, switch port access VLAN 10. Because I want that port channel to be part of 10. That is gig 0/1 of ASA1 and ASA2. So that will connect up to R1. So I'll copy this and I'll paste it to switch 1. Oh, it's the one over here too. After we're done with the class over here, I'll restart my device. Unnecessarily. Okay. This thing. Okay, I'll go to switch 1 over here. Paste it. So if you take a look at it over here, what do I have? This is router 1, part of VLAN 10. Then I have interfaces 11 and 13, the two interfaces from the two firewalls, part of port channel 10, and port channel 10 itself is part of access VLAN 10. That took care of the inside. I need to do the same thing on the outside. R2, this is VLAN 20 now. Let's say 20.0, VLAN 20. So R2F00 should be part of VLAN 20. And then I'm going to create a gig 03 of ASA1, ASA3 is on switch 2. So port 12 and 14 of switch 2 should be part of the same VLAN as a port channel. But R2 is on switch 1, port 2. So for VLAN 20, actually I should do it like this. VLAN 2010 is like this on switch 1. And for VLAN 20, it's on switch 1 for the first port, which is the R2 port. And switch 2 interface range fast Ethernet 5/0/12, 5/0/14, switch port, sorry, channel dash group, let's call it 20, mode active, no shut, interface, port channel 20. All right. So this should take care of switch 2. And on switch 1, I still need some configuration, which is this part over here. That's for R2. That's done. Am I done at this point in terms of the switches, or do I need to do something else? Something very important. I've taken care of the outside and the inside. What do I need to do? Did we create the VLANs that were created yesterday? If not, when I put the port, the switch configures the VLAN automatically. What is that, Tariq? The CL? That is the cluster link, right? So I need to put the two ports that are going to be part of my cluster in the same VLAN. So that's your VLAN 10 and 20 that were created from yesterday. So I'll use, let's say, VLAN 100 for my cluster link. Which port did I say that I'm going to use? Let's say I want to use gig 00 as my cluster link. So ASA1, ASA2, gig 00, I'll make it part of the cluster link, which is 11 and 13 on switch 2. So that would be my VLAN 100. I'll specify it over here. Cluster link network. This again answering your question, Richard, from the earlier part where you specified whether you want to daisy chain it or not. This is where you would put them all in the same VLAN. So in my case, it's 11 and 13. Switch port host, switch port access VLAN 100. Good. This is on switch 2. Because it just happens those two ports are in on switch 2. Didn't copy it. What the hell? Highlight, Control C. Let's look at done. So my switch part is taken care of. Now the important part starts. So my switch part is done. Now I'll take a look at my cluster configuration. What are the different things that I need to do for cluster configuration? I'm going to write that in Notepad first for you guys, explain it to you guys, then I'll paste it. I have ASA1, ASA2. I want ASA1 to be my master and ASA2 to be my secondary device. All of the other guys will be the secondary device. One that I do all my configurations on, I want that preferred to be ASA1. So how do I go about doing that? So once this is done, this is your first step, which was configure the switches to do the physical to logical mapping. Over here on number 2, configure the cluster config on both the ASAs. In my case, it's just 2, but you could have potentially more. ASA1, the first thing that I need to do is I need to specify the mode, interface mode. 2 modes that as I told you, one is span, the other one is individual interface. I'll talk about the individual interface later on. The one that we have talked about so far is span, which is your port channel. Force, if you don't do force, it's going to ask you compatibilities between the 2 devices or not. So this is the first thing that you need to do, change the mode. All right, let me do that over here, right? The steps over here. Step 1, set the cluster mode. Okay, number 2, configure the cluster configuration. What do I need to do over here? I need to create what is known as a cluster group. Give it a name, whatever you want to call it. Sec v5. In here, the first thing I'm going to specify is my host name for the unit that I'm doing this configuration on. That is done by a command called local unit. You can call it whatever you want. I'll call it PRI. I could have called it master. I could have called it main. Anything. It's just a name. A local unit designation. Good so far? Next thing, cluster interface, which is my, I'll say gig 0/0. And the IP of that interface is, let's say, 10.100.100.1, 255.255.255.0. I want it to be the main one, priority, lower the better. Key, optional if you want to, just like we did for failover. And last thing, enable it. And rather than asking for confirmations, I'll just say no confirm. No confirm means enable it. Don't ask me for confirmation. Yes, no, yes, enter, enter, that type of stuff. Good so far? One of the things that I would do over here, though, as my first step that I forgot, is bring the interfaces up. Interface up. Which up? Which interface? This would be 2, and this would be 3. Does that make sense, guys? Everybody okay with this? What would I do on the second box, ASA2? Help me out with that. I would copy this. Bring the interface up, set the mode. Local unit, what do you want to call it? Let's call it secondary. Give it an IP, let's say of 2. Priority, let's keep it as 10. Key and no confirm. This allows the two boxes to talk to each other and form a cluster. All right, so let's do this. I'll copy this onto what? Similar, but not exactly the same. It's the concept's the same, yeah, but not exactly the same. Because it's for firewalling, that is just for port counts. So I copy this, go to my ASA, the first ASA, which is blank. Done. Show cluster info is the command that allows you to test it or check it, check the configuration. I'm the primary, I'm in the state of election. I'm running 9.6.3.1. The cluster control link IP address is this, the MAC address is that. There's no other unit in the cluster right now. Why? I haven't configured the other one. So what do I do on the second one? Same thing, just the IP changes, priority changes, the name changes. Copy it. Enable it. Says, I found the master, I'm doing a configuration replication. Detected cluster master, beginning the replication from the master. I've been disabled to slave. Now I'm the slave. So if I do show cluster info over here, you will notice that it is what? In slave. The other one is in master. Clear so far? Everybody okay with this? The config is over here. We've done that. My two boxes are now acting as a cluster. From this point on, just like we did with the active standby or active, where do I do all my configurations at? Active, what is it called over here? What's the unit called over here? It's not called the active, it's called what? Master. Pri is just the name of the unit. The state is master or slave. Can you highlight the enable command? Enable, you mean what does it do? It enables it. Like you do the failover command to enable failover. Over here, the command is enable. No confirm basically says, don't ask me the, do you want to do this? Do you want to do that type of stuff? No, that's what no confirm does. Good. Now at this time, the cluster is set from, so all the configuration now will be done on the master. So over here, you will also see the same thing. Master is up, slave is over here. There so far? Now I'm ready to do the configuration. I've done the switch configuration already. So how do I configure the port channel on my firewall? Just to form a cluster, what is the criteria? 9.x. Anything above 9.x. But they need to be the same device. So if it's 9.6 over here, it has to be 9.6 on the other side. If it's 9.3, it has to be 9.3. Now, how do I configure this? This is where it gets a little, not tricky, but different. See this gig 01? I want to meet ASA2, the second box. I've done the switch configuration already. I just need to focus on the ASA part now. How do I do the port channel on the ASA? Let's take a look at it, which this is where it gets a little different. So you need to understand that. When I'm doing my cluster configuration now, I've done third step is configure the firewall. Configure the port channel on the firewall. The way you do a port channel on the firewall is interface. I'm doing the inside first, gig 0/1. Fourth, is it? No, see, I'll just put lines over here. Overall, the first step was configuring the switches. So that was a step that I completed over here. Step was to configure the cluster configuration, which was bring the interface up, cluster mode and all. I did that over here, which had multiple steps inside it. And now the third step is, you understand that? So 1, 2, 3 was part of the second step. Got it, Fahad? Now, configure the port channel on the firewall. Gig 01, channel group, let's say 10, mode active, which basically tells me that it is LACP. Now, this is where it gets tricky. How many interfaces did you specify over here? One, right? It actually picked all the cluster members. So I'm not just configuring ASA1, I'm also configuring gig 01 of all the firewalls. So I don't need to go to ASA2 and do that, or ASA3 and do it. When I say gig 01 on the master, it means on all the slaves as well. And then I would configure my port channel. That would be name if inside security level 100 IP address 10.11.11.10 no shot. Similarly, on the outside, the interface was what? Remember, gig 03 is what I picked. Channel group 20. I'm doing it for all the firewalls. When I say gig 03 on the master, it also means on all the other firewalls. Interface for channel 20. You guys understand what I did? So when I'm doing this, I'm doing it for all the firewalls. I'm not doing it just for one. So let's do that over here. Copy. Go to the master. I am the master. Paste it. One thing that I do need to do over here is when I configure the port channel, I need to say this port channel is port channel span cluster. So it's for the cluster. It's not a normal one. So this command needs to be done on both sides. Otherwise, it would not know that it's part of a cluster. So when I'm configuring it, I do need to specify this command. So I'll just do it again. All right, so if we do show interface IP brief, let's just take a look. The port channels are down right now. Eventually it should come up. It takes about 20 seconds for it to come up. Good. So my port channels are up and running right now. I can also check the port channel status on the other side over here. So I can do show ether channel summary. Switch port channel, it's U, which is in use. E is a good thing. Bundle, waiting to be aggregated, so means it will eventually come up. And switch to show ether channel summary. Eventually this will come up as well. So I've done it for both sides. So whenever I do one, it automatically does the other one. There you go. The second one just came up. Both of them will now be in that port channel. This is something else. This is your WLC going up and down. There you go. So now my span port is done. The rest of the configuration is pretty simple. So for example, let's say on the inside, over here, I want to point a default gateway. Who do I point the default gateway to? To that IP address for the port channel. That is correct, yes. So on R1, I'll configure R1 over here. No IP, domain dash lookup. So if I make a mistake, it doesn't log sync. And now I'll configure my IP address. My default gateway is .10, line VTY0 space 4, Cisco login. So ASA is done. Oh, sorry, router 1 is done on the inside. Let's do router 2. While router 2 comes up, I also want to do my NAT so that I can, from this point on, the rest of the stuff is the same. So object network, what I've taught you already, range 20.51 through 20.100, let's say. Object network, INSNet, subnet, dynamic, pool 1. Spelled it. Pool 1. Now let's go to router 2. So router if I go on router 1, which is on the inside, telnet to 192.20.2, should go to router 2. It does take that one hit sometimes. There you go. I'm in. Show users. It should give me that IP address in that particular pool. So if you had to follow this, how did I go? Which one did I take over here? Help me out with that. Absolutely. Depends on the port channel algorithm. So I'm not sure which one it took. So it went into the switch because it's a port channel. The switch might have sent it this way. Switch might have sent it this way. The hashing of the switch will determine which flow, which ASA will it go to. But that's the beauty of it. It's actually doing what? Load balancing. Do you get 200% utilization? You don't. If you add 100 and 100, which is 200, you don't get that. You get 70% utilization out of the two. So there is an overhead that is also taken care of, but at least 170 and 70 is what? 140% utilization is what you get. You don't get 200, but you at least get 140 on an average in terms of the traffic flow, in terms of the utilization that you're getting. Clear, you guys? Everybody okay with this? This is the preferred way of doing clustering. Right now, if you look at the numbers, active standby is a lot more in terms of the number of implementations versus clustering, but not because it's not good. The reason for that is the install base is higher for non-cluster type of setup. The other thing is a lot of the people work under the premise of if it's not broken, don't fix it. But in terms of capability, clustering is way better. Active standby, or for that matter, active. That is correct. Based on the flow of what? Which is controlled by whom? It's actually not controlled by the ASA, it's controlled by the switch. You guys okay with this? And the commands are already there, right? Did I miss anything? The port channel is done. You could have configured the firewall. A was configure the port channel. We did that. B, maybe configure a default route. It's called span mode when you do port channel. That is correct. Span mode is port channels. Inside, outside, dynamic. everybody okay with this? So I'll save this over here under security. Day 9. Good. Everybody good with this? Now, the next one is the individual interface mode. What is that? Let me explain that first, and then we will do it. This is a non-preferred way of doing it. In this particular mode, I don't set up any port channels. The individual interface mode is the non-preferred one. No port channels over here. The way it's done, firewalls. Although there's a master, both the firewalls will get their individual IPs. Remember, I had the IP over here as what? In the older example, the IP was assigned to whom? To the port channel. Here, I'm not going to create any port channel. Every device will have its own IP address assigned to it. This one requires a router on either side to run some type of routing protocol. It will form a neighbor relationship with both the routers, both the firewalls, sorry. So if I had a route over here or a default gateway, it would have sent the route to him and to him. The cost is the same segment. ASA1, ASA2 would have forwarded that same network to R1, same cost. So when the router gets a packet that is destined to either to this network 2222, it will use a mechanism known as equal cost load, also known as ECMP. So if you want to do individual interface mode, the actual load balancing is done by ECMP. Each firewall in that particular will be using routing to do load balancing. The reason it's not preferred is because, first of all, the convergence times of the routing protocols is much higher. All right, and in terms of utilization, it's much higher on the firewalls as well as on the routers. Port channel is the preferred mechanism doing the other way to do it. You guys clear on this? So let's go ahead and do this then. I will save this as file save as. I added up 7, so this will be 8 clustering span mode. So in this case, firewall is running normal, or do we still have to configure the master configuration? Meaning, in the interface config mode, the cluster configuration, you still have a master, but you will notice when I do this, there's a special way of doing it. You still do the configuration on the master, but the way it's done is a little different. So it's done differently. You still do all the configuration on the master. All right. So in this type of setup, the new one that I'm going to do now is I am going to have a firewall on the outside. I'm going to have the outside segment connect up. I'm interfaces now. No port channel. Connecting to the two firewalls. Okay. You will have the cluster control link over here. You would still have this stuff connecting here towards the inside. But this is your gig, let's say 0/3. And this is still your individual interfaces now, not part of a port channel. This is router 2. This type of setup. So first things first, let's blow off the ASA1, clear configure all. The only thing that you need to be careful about over here, unlike all the other configs that go away with the clear configure all, the cluster configuration, you need to manually do it. To remove it, you need to do it manually. The clear configuration all will not get rid of it. Just remember that. Do this, plus also do your no to get rid of it, to make it into a non-cluster mode. Otherwise, it would still remain as a cluster mode device. Router 1 is okay, router 2 is okay. I don't need to do too much over there. The switches I will do again. Default interface range, give 2/0/1 through 20. And this guy, the same thing on done. So what are the different things that I need to do over here? Now, unlike, I still need to do the switch configuration. So I'll just copy this and I'll show you the differences as we go through it. Clustering, I'll say span mode. Or this part of the clustering was the same actually. Span mode started after this. So this is your Okay, physical to logical, VLAN 10, which is on the inside, this port. Now over here, change, but I don't need to do what? Port channel, just make them part of the same VLAN. So technically I could have done this, because all the 3 ports are in the same switch. Copy, because I'm not doing a port channel. So that's VLAN 10. VLAN 10, if you take a look at it, is this guy over here, R1, gig 01 of ASA. I haven't put the names of ASA1 and ASA2. One of ASA1, ASA2 is 11 and 13, and R1 should be in the same VLAN. That's exactly what I'm doing over here. 11, 13, and 1 on switch 1. So copy it, go to switch 1, paste it. Copy it. So strange. Finally took it. So good. The next one is the outside VLAN. Again, gig 03 and R2F00. R2F00 is on switch 1, so this is okay. Switch 2, again, same thing. The ports normal, put them in the same VLAN. So let's do this first. Copy it. This is done. That's R2. And then the gig 03 of ASA1, ASA2. I'm doing over here. Took care of that. And the cluster link doesn't change. Cluster link was exactly the same either way. Just put them in the same VLAN. This is on switch 2, port 11 and 13. Done. In VLAN 100. So my switch configuration is done. How about the cluster configuration? What do I do in the cluster configuration? ASA1, bring the cluster up, mode. Interface mode, individual. Cluster configuration, same type of thing. Private, the interface, the IP, priority, key, non-confirm, everything the same for the cluster interface configuration mode changes. On which we moved the earlier port channel. We had 1 port channel on switch 1, 1 port channel on switch 2. The inside one was on switch 1, the outside one was on switch 2. Because I had 2 port channels. Copy. Change this. The rest remains the same pretty much. So even with the individual interface mode, this part remains the same. Yeah, I did. That's what I'm saying. We removed the earlier port channels by using the default on both of them. So this is on ASA1 to make it into a interface individual cluster. Right over here. And on 2, same thing with a higher priority, different IP. Let's go to 2. Got it? So that's taken care of. Show cluster info. Show cluster info. Individual mode. Primary CRI, which is the one that I'm on, is the master. The other one is secondary. I'm doing a bulk sync right now. That means I'm still doing the setup of the cluster. There you go, the slave. So my setup is complete. You guys okay with this so far? Now this is where the changes come in, because before I had a port channel. Now I don't have a port channel. I'm doing it based on individual interface mode. Now the way you do it, because your configuration still is only done on the master, you need to create a pool of IP addresses that I'm going to be assigning to the other devices on the outside as well as on the inside. All the configuration again is done on the master. What type of configuration do I need to do? Configure the firewall. In here, configure the IP addresses on all the interfaces. You need to create a pool to accomplish this. Let me explain this to you guys. Everything is done on the master, by the way. I don't have this 4-channel configuration type. So I will blow this away. The way you do that is I create a local pool. Let's call this pool outside for IP addresses on the outside. I'm going to say 20 dot, let's say 11 through 20 dot. I only have 2, but let's say I want to keep 5. IP local pool inside 11 through 20.15. Sorry. Good. So I created these pools right now. What are these pools going to be used for? Interface gig 0/3. This is gig 0/3 of all the interfaces. Okay, give it a main IP. This is on the outside, so I'll say 20.10. Everybody else to get an IP address from the cluster pool called outside. So every device will get its IP address from the pool called outside in this particular range. The rest of the stuff you still need to do, like what? If outside security level 0 and no shut. Similarly, I will do what? Gig 01 inside 100 10.11.11.10 cluster pool inside. So each one of those devices will get an IP address from this pool. Do you get my point? So I'm not assigning IP addresses individually to go to each and every device. Rinchen, you had that question early on, right? Do I configure each device or do I still do the master? Do you understand how it's done? So if I copy this over here, I just copy it to where? Only on the master device. As one side is done, the other one was not done. Says, hey, listen, I cannot communicate to the other side, so I'm gonna shut it down. That's okay. This one will right now, and then it'll eventually the other one will come up. Show cluster info. I'm the master. The other one eventually come up. Sometimes what happens is when you paste it too fast, it hasn't come up already. It thinks that the interface is down. Show interface IP brief. And you should have an interface IP assigned to administrator down. Did I do a no shut? Interface. There you go. So it's got an IP address. That's your config. Show IP addresses. The inside and the outside addresses. The system. And these are your. So this is my IP address that I'm using right now. The .10 because I'm the master. That's the only reason I have it. Eventually, it will come back up. So show cluster info. Okay. One second. All right, so this is now show cluster info. I'm the master, and the other one is replicating. So eventually, it'll become the slave. Good. All right, now the IP addresses are there. So if I go to ASA1, interface, IP brief, and you will notice that I have been assigned an IP address, which is .11 and .11. Now, how does the actual load balancing take place? That's done based on routing. Let's run EIGRP as come up. So what I'm going to do over here on my master, which is ASA2, right now, router EIGRP 100, no auto, network 192.1.20.0, network 10.0.0.0. I'll go to router 1, router EIGRP 100, no auto, network is 10. Yes, they do. Now I have two EIGRP neighbor relationships. I take a look at my show route. I will learn the 20 route via two places. So my actual load balancing will be done based on that. If I want to go to the 20 network, I have 11 and 12, equal cost. So I'm going to send one packet here, one flow there. And on R2, I'm going to do the same thing. Router EIGRP 100, no auto, network is 20.0. I'm also going to advertise a network 2. I have this loop back over here, and I'll create a loop back over here as well. show IP route. So the load balancing is taking place because of what? ECMP. So in order to get to 2 now, I have 2 different paths to get there. The rest of the configuration that I need to do is basically the same. Okay. So once this is done, configure the routing protocol. So your actual load balancing is based on the inside routers, inside and outside routers, and the file, which is only on the master. So on the master, router EIGRP 100, in my case, 20.0. And if you want to be more specific, you can always do this on R1, which is on the inside. I have the one network over here that I advertise on R2. This is what I had over there. C is NAT. This remains NAT portion. So copy it and I'll paste it onto ASA1. No, ASA2 is the master. You guys okay with this? So now if I go out, I can use one path or the other path to go out based on the load balancing. The load balancing this time around will be done based on the ECMP part of it. So over here, when I sit over here on inside, that is correct. The ASAs between them will state table, state information. But the actual load balancing is done by the inside or the outside routers. It's not actually done by the ASAs. In clustering, you need to remember whether it's span mode or the interface config mode. The clustering actually is done by either the switch in case of span based on the port channeling algorithm or by the individual interface mode. So if I do a telnet right now to let's say 2.2.2.2, it'll go this way or that way. Should go there. Why is it not connecting? We configured NAT, I believe. Yep. Show xlate. And when was translated to 20.61. Well, let me try it with this, the source, because it's on the same network. NATing might have an issue. There you go. It's working. So it's going through. All right, so it's done based on routing over here rather than the load balance. Can all these be done on GNS3? Clustering, no. Requires you to do it on the physical boxes. All right, so if you take a look at this, the NAT, the routing, everything is done. So we have looked at both the types. The reason, again, you don't want to do the individual interface mode is because you're now depending on the routing to do your load balance. So these two things are done. We'll take a break. We'll come back and take a look at your site-to-site configuration. The VPN configuration. Clustering can be done in routed mode only for the for the individual interface mode. For the other one, you can do clustering with span mode for your layer 2 transparent firewall. Because the routing is only required for individual interface mode, not for the other one. This is my 51. Let's take it till 310. When we come back, the VPN section over here. All right, break time. All right, guys, what I'm going to do right now is I'm going to erase the configs and reset the topology or clean it up. And in the meantime, just hang in there. You'll just see what I'm doing. As I said, clear configure will not get rid of cluster config. So you need to do that manually. So I shall do that over here. All right. So first things first, let's go ahead and set the topology up so I can set up your IKE v1 as well as IKE v2 VPNs. IKE v2 will be an issue. Let me just save this first and then, because my IKE v2 will be, I'll do a router IKE v2 between firewall to firewall. Or can I enable it? 1 second. Let me check this first. ASA 9 clustering individual interface node. So this is done. I'm going to check something over here. Do I have? Okay. Give me 1 sec. 7200 router. That's up to the cloud. Switch. Doesn't matter what it looks like. Let me see if it works, and then if it does. Okay. Okay, this is my port that connects to I don't know if it's on switch 1 or switch 2. It's on port 23. I maybe over here, but we'll figure that out. But this is that connection towards my router. So that's where my router for my VPN will come in. So now setting the topology up over here. Let's get paint. Um, okay. I want to do different type of VPNs. So one of them is ASA1. Connects up to, we'll put a router in the middle. We'll put a connection towards this ASA firewall. And then this is going to be my first VPN. The second VPN I'm going to do is from this guy over here. Bear with me, I'll just set the topology up and then see exactly what we're trying to accomplish. This is that router over there. So those are two VPNs. And the third one will be my inside device. Okay, got it. I just want to do one topology and try to knock out all my VPNs in one shot. So this is router 1, router 2, router 3. I'll call this the 7200 router, which is on the outside. And I shall connect a PC over here as well. Okay. My networks now that I have over here are, I'll call this 192.1.30.0 network, which connects up to ASA2. This is ASA1. This network over here is 10.11.11.0. And this VLAN is 10. This VLAN over here is 30. I'll put a router over here that will act as the router inside. And this is going to be router 4. 10.40.40.0. VLAN 40. .192.1.23.0. VLAN 23. This is 20.0. VLAN 20. And this is VLAN 100. And the network will keep as 100.0/24. All right, now the interfaces over here are interesting because R2 just has 2 interfaces, but as you can see over here, I'm putting multiple interfaces for R2. This thing, I don't know why it's just hanging today. This is F0/0.100, which is going to be part of this VLAN 100 over here. This is F0/0.23. I'm just using one interface on R2 to do all that. F0/0.20. This is PC. I'll put it as 200. And the network over here for the PC, 192.1.200.0. Okay. And the last network over here is this guy over here, F0/0.20. So I have 4 sub-interfaces on R4. Let's set up the topology, and then we'll set up the VPNs for it. Let's start by one VLAN at a time. This is the inside network, so we'll say gig 0/1. And the outside we'll say is gig 0/0. Same thing over here. And this guy over here is gig 0/1. So we'll start with R1 and ASA1 to be in the same VLAN. 10.11.11.0, VLAN 10. So the switch side, R1 F00 and gig ASA1 gig 01 should be in the same VLAN, which are these two ports, R1 F00 and ASA1 gig 01, 1 and 11 in the same VLAN. So let's just do that real quick. Switch 1, interface range, gig 2/0/1, gig 2/0/11, switch port host, switch port access VLAN 10. That takes care of the first VLAN over there. One and 11 in the same VLAN. The second VLAN that I have is VLAN 20, which is gig 00 connected to R2 F00, which is a sub interface. So I'm going to do trunking on that. ASA1 gig 00 and R2 F00, which should be a trunk. Let's do the trunk first. Interface gig 2/0/2, switch port trunk, incap.1q, switch port mode trunk. So that takes care of R2, all the interfaces over there. And the next one is ASA1, which is port 11 on switch 2. Switch 2. Fast. VLAN 20. So that takes care of this VLAN as well. R2 is taken care of. This is the PC, which is port 23. Okay, I'm going to put this also over here on 100. So these two, because the PC and the port are using the same one. So this part over here, I am going to erase. This is going to be all deleted. Okay. My PC will also be over here on the same network. As this guy. So this is port 23. This is port 23 on switch 1. That is the PC as well as the router. R2 is already trunked, so this PC should be in VLAN 100, which is port 23. So that takes care of that. This is done, this is done. Now this one is taken care of already because of the sub interface. R3 F00 should be in VLAN 23. So R3 F00 is port 3 on switch 1. So that takes care of that. So this is done. The next one is R3F01 and ASA2 gig00 should be in the same VLAN. Where are those two ports? R3F01 is port 3, gig00 of ASA2 is 13. So 3 and 13 should be the same VLAN. On switch 2. Interface range, fast Ethernet, 5/0/3, 5/0/13. Is, let's say 30. That takes care of that. That's 3 and 13 over here. This is gig01 and R4F0/0. So ASA2 gig01, which is 13 on switch 1 and 4. 4 and 13 in the same VLAN, and that should cover it for all of them. Interface range, gig4, 2/0/13, I believe. E01. Yeah. Either 40 should be there. Yep. Now let's set the IP addresses and see if we can start pinging. Again, from the bottom up, R1 and ASA1 inside should be in VLAN 10, which it is already in. IP addresses need to be set up. So R1 and ASA1. R1. No router EIGRP 100. I'll default the interface. IP address 10. IP address 10.11.11.1. Show IP route. It's already pointing to 10, so this is good. ASA1 interface gig0/1, which is the inside. Should be able to ping 1. Give it some time. There you go. Let's go to the outside now. Route outside 00.192.1.20.2. Router 2 is the tricky one. Take care of this. No shut. Now my first sub interface is colony.20 in cap .1q20. So VLAN 20, IP address is 20.2. Should be able to ping 20.10. Give it some time, it should come in. Because it takes, because of .1q, it takes about 30 seconds for it to kick in. So R2 can ping this device. All right, let's do the same thing over here from R2 towards the PC, and also this other box that I have over here. What interface is it? It'll come up, but the IP address on that PC, open networking, this is the PC that I'm going to be using over there. Adapter settings, this is that management PC that we talked about. We'll put this on the 100 network. .90 is the IP address over here. All right, so 100 is the VLAN. Interface fast Ethernet 0/0.100 incap.1q100. IP address is 100.2. 100.90, I believe, was the IP. There you go. I can ping the PC, or on the PC if I want over here, ping 192.100.2. So I can ping that device. Let's see if this guy is up. It seems like it. This is the 7200. I'll need this for the IP2. So over here, I am going to do interface fast Ethernet 1/0, 100. Let's say 72. This was 10, yeah. Where did this go? 100.90. Should be able to ping that. Oh, no. Or 100.2. If not, that's okay. Yeah, there you go. 100.2 is pingable. That's more important to me because it's going out. Good. So this one is done. This one is done. Now the next one is towards R3 VLAN 23, which is another interface over here. Interface fast Ethernet 0/0.23 incap.1q 23 23.2. All right. Now to do the other side, which is R3. We'll also bring R4 up. So I'm setting this topology up. In this, I'm going to set up different VLANs. We're almost done with the topology. R3 now. Interface F0/0 is 23.3. And I should be able to ping 23.2, which is router 2. Good. F0/1 is 30.3. And this guy as well, I'm going to set the default gateway towards the internet, which is 23.2. So I should be able to ping 20.10. So right now R3 uses R2 as the default gateway to hit the ASA. So that part is done. This interface is done. I just need to do ASA on the outside, inside. ASA on the outside, ASA 2. gig 0/0, name if outside 30.10. Should be able to ping 30.3. No problems. Gig 0/1, name if inside 10.40.40.10. Route outside 0/0. Where's R3? Last device, router 4. Interface F0/0. And bingo. And let's see if the routing is done completely. Let's check. Okay, over here, this one has a default gateway pointing here. This one has a default gateway pointing here. This one has a default gateway pointing here. That is not a problem. This one has a default gateway pointing here. That's okay. I need to create a route default gateway over here pointing towards this guy, and this one a static route over here. We'll do that later on. This one has a default gateway pointing here. So R2 just needs to know about the 30 network. The rest is directly connected. So we'll do that, and we will be done with the routing. R2 192.1.30.0 through 23.3. So I should be able to ping 30.10, which is the ASA. All right, so this is done. I want to do different type of VPNs. The first VPN that I want to do is IKE V1 between ASA1 and R3. We have done that router to router. We have not done it from ASA to router. That's my objective over here. So I want to set up a tunnel to encrypt traffic from, let's say, 10.3.3.0 towards 10.11.11.0. That's my objective over here. Everybody okay? Follow along with that? You guys understand what my objective is over here? Something is fishy today. Come on. Okay. Can I get my chat window? All right, so my objective over here is my first VPN from ASA1 to R3. How would I do it? Do you guys remember how do I do a normal VPN on a router? So this is the one that I'm doing right now. IKE V1 from where to where? On ASA towards R3. So R3, how do I do a VPN? Remember the steps? Step 1, phase 1, crypto, ISACAMP, policy, and auth pre-share, encryption, triple des, hash MD5, group, let's say 2, Just use SHA over here. Group 2, crypto, ISACAMP, key. 1 second. Power. Okay. Key is Cisco 123. Address is going to be 192.1.20.10. Phase 2, crypto, IPsec, transform set ABC, ESP triple DES, ESP MD5, HMAC, 3, ACL, interesting traffic, access dash list 11, permit IP 10.3.3.0 towards 10.11.11.0. 4 is your crypto map ABC 10 IPsec ISACAMP. Match address 101, set peer 20.10, set transform set ABC, I believe. And the last step, crypto apply to the outgoing interface. Everybody okay with these steps? Yeses, please. I'll copy this. I'll go to a router 3 and paste it. So this part you guys are okay with. Now, how do I do the same thing on the firewall, on ASA1 to set up the tunnel from my side? One of the things that you do have over here is a concept called VPN setup on the firewall. I'm setting up a site-to-site IPsec tunnel for steps. Now what it does is it gives you the exact steps that need to be done to configure a LAN-to-LAN tunnel over here. Between what? Between the firewall and another firewall or another router. It's a site-to-site VPN. So on the exam, you do have the ability to go back and take a look at it to see what the commands are. You understand that? So if you want, you can actually use this command. It's called VPN setup to see what the steps are to set this up. But over here, I'm going to do it for you guys. Oops. I'm going to start with the way I look at it. You guys remember the first thing that I told you about in terms of access to the firewall or through the firewall? Remember that? When I'm setting this tunnel up, am I sending the traffic through or to the firewall? My tunnel is from where to where? R3 to the firewall. So if that's the case, I need to enable the traffic to the firewall. The ACL will not help. I don't need an ACL over here. It's not through traffic, it is through traffic. All right, so that's the first thing that I would do over here. Crypto, ISACAMP it doesn't exist anymore. Enable, or does it? No. Yeah, they've taken it out. ISACAMP in this particular version is IKV1, enable outside. You understand that? So this basically specifies that I'm allowing an ISACM tunnel to be terminated on the outside. Then you can do your policy. Again, I think they have taken everything off too. I need to copy these policies over here that I set because I don't remember them. Do you see the subtle difference in the commands? This is what I've done so far. So on the ASA, for step 1, which is what? Phase 1, the commands are like that. Not only that, now when you set up your pre-shared key, how did I set the pre-shared key? Crypto ISACM key and all? Here the commands are different. It's done based on what is known as a tunnel group. Specify the IP address that you want to set it to. My IP address that I'm going to set it to is 23.3. Type IPsec L to L, LAN to LAN. So I'm setting up a tunnel group, which is going to be to a destination of 23.3, which is R3's address, for a site-to-site tunnel. And then I'm going to set my attributes over here. IPsec attributes, and in the IPsec attributes is your pre-shared key. IKV1, pre-shared key, Cisco 123, enter. So step 1 still, this is setting the key up. Good. So that's phase 1 or step 1. Same things, commands are slightly different. Step 2 is same. This step is identical, so I don't need to change it. I can actually paste it over here as well. So that takes care of my second step. My third step, just want to make sure it's taken, is my ACL, which is also the same with a subtle difference. It's an IKV1 transform set. That's okay. IPsec transform set it. So I'll just put that in for you. All right. Step 3 is the same. What is that? ACL. The only difference is, I'll just call it 101 just for the heck of it. Permit IP 10.11.11.0. You're using the normal mask, not the inverse mask. Step 4 is also the same. Crypto map. The only difference is the way you do it is a little different. And you don't have a subconfig mode. You do everything over here. Thank you. Excuse me, man. Catching a cold over here in London. Oh, ACL I didn't copy. I just did it over here. Actually, just copy that. Well, okay. So I got that done. The last thing is to apply it. How do I apply it? Slightly different, but concept's the same. Interface, outside. Now, this over here, you need to match the interface. If I had called interface outside with uppercase, if you had called it outside with an O uppercase, you would have to match it. And I'm done. So almost the same with subtle differences over here, as you guys can see. What is that, Joshanda? Yeah, man, I need to get some medicine. Otherwise, I'm going to be completely out tomorrow, which I've done now. And that's it. That's how you set it up. Slight differences here and there, but overall, the 5 steps remain the same. The syntax changes a little bit. So now, if I go to R3, create a loopback, 10.3.3.3. Ping 10.11.11.1 sources. There you go. Show crypto. ICAMP SA. My tunnel is up. Show crypto. IPsec SA. My packet should be encrypted, decrypted. Everybody okay with this part over here? Same concept, slight differences in the commands. The next tunnel. This is an interesting one. What this mean and required to match or not. 8600, 86, remember there's 2 tunnels? You have phase 1 and phase 2. Phase 1 has a lifetime of 86,400 by default. If they don't match, it takes the lower number. So for example, let's say one router has 86,400. The other one has, let's say, 28,800. It's going to negotiate down and use the more aggressive number. Aggressive means a shorter lifetime. It's in seconds. This is the lifetime for phase 1. Got it? Now my second tunnel is going to be IKE v2. I'm going to do it from ASA2 through the firewall towards this router 7200. And what I've done is I've connected GNS to my rack. So I'm going to do it through GNS, connect up to ASA2. So first thing, let me see if I can ping it. If I can ping it, then I need to ping 192.1.30.10. Okay, it is now pinging. Can I ping 100.2? All right, this is good. The reason is bingo. So this is where I'm at. I want to set up a tunnel to this guy. But this time around, I want to do IKE v2. To encrypt traffic from 1040, I'll create a network over here, let's say 10.99.99.0. You guys understand it? So my tunnel is from this guy to that guy. Let's do the IKE v2 on, what do you call it? On the router, because you know how to do it, and then we'll do the same thing on the firewall. So help me out in terms of setting up IKE v2 on the 7200. How do I do it? Let's do it in Notepad. So now I am doing IKE v2 now. This is going to be between ASA2 and the 7200. 7200 router is what I'm going to do this on. Step 1. Remember, step 1 was 1A was the proposal. Okay. How do I set the proposal? Crypto IKE v2 proposal. Prop 1. Let's set my integrity to SHA-1. My encryption, triple DES, and my group to 2. My second step was 1B. Policy. Prop 1. 1C. Keyring. Again, these are the same steps we went through when we did the normal IKE v2. I'm just repeating it. I just want to do that on the ASA side now. Crypto IKE v2, keyring, KR1, peer will say is ASA2, just a name. Address, or we'll just use different keys. Address will be 30.10, which is the IP address of ASA2 outside. Pre-shared key, local. Let's say Cisco 111. Pre-shared key, remote, Cisco 222. And the last step in this was 1D, which was your profile. Crypto IKE v2 profile prof 1 match identity. Remote address was 30.10. Authentication. Local was pre-share. Authentication remote was also pre-share. And the keyring was KR1. Let's paste this to make sure that my phase 1 is set up properly on the router. I'm already there. This is done right. This looks it's okay. This looks okay. This looks okay. So phase 1 is done. Now let's move on to phase 2. Crypto IPsec transform set ABC, ESP triple DES, ESP MD5 HMAC. Step 3 was your interesting traffic ACL. This doesn't change, by the way. Access-list 101 permit IP 10.99.99.0 to 10.40.40.0, which is on the other side. 4 was the crypto map. Set peer 30.10. Set transform set ABC. Set IKV2 profile prof1. And the last step was to apply. Oops. Interface is fast Ethernet 1/0. Crypto map ABC and apply it. So just copy all these steps from phase 2 onwards. All right. Looks good. Everything's good. I just need to create that 10 dot the loop back over here. 1099. That's good. Now, how do I do the same thing on the ASA? It's a little different over there. Similar to what we did over here for this stuff though. For ASA1, I'll copy this part and change it wherever the need is there. So this is on ASA2 now. Phase 1, it'll be IKV2 enabled. And this thing is different, so I'll just copy this first. And go to ASA2. Enable IKV2. IKV2 policy 10. And then you can just copy this stuff. The one that I was doing on the other side. Integrity SHA triple res group 2. Because that needs to match. Integrity SHA. What do they have? SHA is SHA1. So this is good. Over here. SHA is SHA1, and this takes care of that. The authentication is a little different, although the IP address is 100.72. 100.72. This is the IP address of that router over there. Once I go there, come on, I don't know why it doesn't. Copy. There you go. IKV2. And then you specify your local and remote. So local authentication, pre-shared key is, I need to check because it needs to be matching. So local is what used to be the remote on the other side. All right, and similarly, remote is 111. So if you take a look at your show crypto, show tunnel group, sorry. This is how you do your key, which is similar but a little different. Cisco 111 and this is Cisco 222 because remote is 111, local is 222. The next thing is your IPv2. It's a little different over here. Crypto IPv2 transform set. Actually, it's called IPsec proposal. IPv2 IPsec IPv2 proposal. IPsec proposal. It's a command. ABC, enter, and this is where you specify your ESP as your protocol. So the command is a little different over here. Protocol is ESP, and the encryption is triple des. Protocol is ESP. The integrity is MD5, I believe. So this is the command that is there that replaces your transform set over here. The IPv2 proposal is for both the encryption and the integrity. This is your transform set. So the command set completely changes over here for this one. All right, ACL, that is similar. 101, I'm going to do it from 1040 to 1099, if you remember on the other side. All right, so I'll copy this, paste it over here. My ACL is done. The next thing is to apply it. So to apply it, crypto map, let's call it ABC, and Ike v2. Okay, hold on a second. Match address and all that type of stuff, they'll do the same way. Set here is the same. And the third one is the difference. Set Ike v2 IPsec proposal, and what did I call it? I believe ABC, but we'll just check. Yeah, ABC. Still call it ABC. All right, and the last thing is just to apply crypto map ABC interface outside. See, notice it said interface outside is not found because over here it is case sensitive. So this is done. Let's do a show run crypto map. We'll copy this over here. And we should be done with this one as well. And that's it. So now, if I go to the guy over here and I do a ping to 10.40.40.4, I believe. Source loopback 0. And my ping is working. So if I check show crypto IPsec SA, I have 4 packets encrypted, decrypted. Where am I going from? I'm going from this guy over here, which is 10.99.99.0, and I'm pinging this guy over here, 10.40.40.4, through the tunnel. The tunnel is from here all the way to here. That is IKE v2. So you have the comparison between IKE v1, IKE v2, both on the ASA as well as on the routers. That's the reason I wanted to set the topology up in this way. The VPN that I'm establishing on the same topology. Any questions so far? What if the tunnel, you need to understand, when do I set up a VPN? First, I'm going to answer that question as well, but look at it from a practical perspective. Where do I set up a VPN between? Generally. Between two sites that belong to the same company, correct? Right, Manjinder? Manny? Normally when you set up a VPN, yeah, but normally, right? To connect two private sites to each other. VPN means private to private over public. So 99% of the time, what you'll have is you have two private networks belonging to the same company. So you will not have a conflict in IP addresses. Normally when you do it with a partner, you use public addresses to connect up. But let's say you did want to connect overlap. You have the ability to NAT that address. NATing happens prior to IPsec. So if you're doing NATing and you've done the NATing, you specify if I want to go from 1040 to, if I'm going from 1040 to the public address of the guy, translate it out. So you set up NATing prior to IPsec. So you would translate it and then do IPsec with it. Make sense? But again, that is very, generally when you do a VPN, you do it based on private to private. But that's where you would use NATing if you had that issue. The last thing I want to do over here is I want to be able to do a web VPN where I want to connect up from a browser. Oops, time's up. I need to reconnect. All right, we'll come back into it. Before we do that, what I want to do over here, I want to set up a PC to connect up using SSL as your protocol to set the tunnel up. On the ASA, there's one type of VPN known as the web VPN. What is the web VPN? It allows you the ability to connect up using your browser as a client into your ASA to get access to your 10.11.11.0 network. Yes, this is also known as the clientless VPN because client software on it. This is known as the clientless VPN. Now, that's what I'm going to be doing
from your PC into the ASA to get access over here. But one thing that you need to understand over here, this is also known as what is called the proxy-based VPN. What I mean by that is up to this point, whenever I was accessing the VPN, I was using my local IP to communicate to his local IP. In the SSL type of VPN, what I'm going to be doing over here is that I'm going to be allowing access from the PC through an SSL setup towards ASA1. 1 second, let me, I don't know what happened there. In this type of setup, what's going to happen is this PC, which has an IP address of, let's say, 192.1.100.90, this is a public address, he's going to establish an HTTP packet, which will have a source of this address, and a destination will be 192.1.20.x. Inside the HTTP header, he's going to that he wants to access R1. But that request will be inside the packet itself. Natively, in this type of VPN, the three protocols that are accessible are HTTP, FTP, and the Windows file share CIFS. Those are the only three that you have the ability to send the request to over here. When the request comes into the ASA, ASA takes the request from 100.90. 100.90 is not represented on this network. So what the ASA does, it sends a request on behalf of the ASA to R1 or the internal devices don't see the request coming in from here. They will see the request coming from ASA over here. All right, that's why it's called a proxy-based VPN, because the ASA will proxy on behalf of the remote client. You do have the ability, if you want, to do what is known as port forwarding, which connect up and use other ports to connect. The problem with that is it is Java-based. It is Java dependent. So if you don't have the correct version of Java, you will have issues with this one. But let's see how to set up this web VPN to connect this PC over here to your ASA. My PC over here is the PC viewer. So let's go to TeamViewer over here. Something strange today on this PC over here. So this is the PC that I'm talking about. I'm going to create a route over here. To be able to communicate to, for this PC to have a route to communicate to. I don't want to set up a default gateway because the default gateway I want is towards the internet. So I'll say I add route add 192.1.20.0 should go through 100.2. 100.2 is my router 2. So if I ping 20.10, should be able to ping it. So the PC, this PC over here, is able to connect up to R2, R2 to ASA. That's the ping that I did from the 100. Network in towards the ASA. All right, what I want to do on the ASA is set up web VPN. All right, so how do I do it? What are the different steps that I need to do so that this PC can access R1? Let's take a look at it. So I'll go back onto my ASA1. Over there, I do web VPN, enter, enable outside. So I'm allowing web VPN capabilities on the outside. Show run web VPN. All right, in here, by default, it has the enable AnyConnect Essentials. This one does not give you the license for doing clientless VPN. So what you need to do is in here, you need to specify AnyConnect. No AnyConnect Essentials, I believe. We'll check that. Disable it. So let's check. Disable this AnyConnect Essentials. So you will be able to do. You need to have a special license if you do AnyConnect Essentials. So the first thing that I did was I enabled web VPN on the outside interface and disabled AnyConnect Essentials. I believe that is the case, but let me verify it once we do it. So now I'm doing the web VPN clientless. So step one, enable web VPN on the outside interface and disable AnyConnect Essentials. Done. The next thing that I will do is I will create a group policy that specifies my protocol to be AnyConnect. Configure a group policy to specify AnyConnect client. So over here, the way you do that, group policy, let's call it sales, just as an example. This group is local on this particular device versus being on a ACS server or ICE. Once it's done, you specify the attributes. In the attributes, you specify your VPN tunnel protocol. You have a choice between IPv1, IPv2, SSL client, SSL clientless. I'm going to pick the SSL clientless. All right, 1 second, guys. Yep. I don't know why. Okay. So on the PC, I typed in https://192.1.20.10. And here, as soon as I did that, the packet was created from my PC, destined to I don't know what. It just disappears on me. One second, guys. When I type in over here, https://192.1.20.10, it creates a packet from its PC. PC's IP address is 1.100.90. This is the source. Destination is going to be the address that I want to go to. This is an HTTPS packet. It logs in. Once it logs in, it shows you this screen over here, the one that I showed you right now. In that screen, if you take a look at it, I'll go back to the home screen over here. You have the ability to use HTTP, HTTPS, CIFS, FTP. So from this screen, you have the ability to access any of the servers inside the network based on these 3-4 protocols. These are the native protocols that we have. When you send the request in, let's say I just browsed to the 10.11.11.1 network, I send the request in, it came in inside the data portion of the HTTP packet, which sent the request in as HTTP to 10.11.11.1. Firewall receives it. The firewall then creates a packet where it will source the HTTP packet interface towards him. So that HTTP packet that actually hits R1 is proxied from 10.11.11.10 towards 10.11.11.1. So the user from the outside now has access to any of these servers. Does that make sense? That's why it was called a proxy-based VPN. I didn't need to install any client on the PC. You just did it based on the browser. The browser was my client. But let's say I wanted to access non-HTTP, FTP, or CIFS resources. Let's say I want to do Telnet in. Or for that matter, I wanted to get into a SQL database over here on this network. These would only give you access to what? These protocols. So for that, with WebVPN, which was called port forwarding. So I'll log off for right now. I'll go back into my firewall. In my WebVPN, global WebVPN, I would go in and I'll create a port forward. For example, I'll say, so for sales, for example, I'll pick a port number, any non-standard port number, let's say 29,000. Pick a number, and I'll say anytime the user uses 29,001, send the packet to 10.11.11. Let's say 19 for port number 1521. So you tell the client, the user, when he sits over here, that rather than going for the database using the normal port number, which is 1521, I want the client to be configured to telnet into 127.0.0.1, which is a local box, but to a port number 1. What happens over here is as soon as a client launches, he will have a Java redirector. The Java redirector will intercept the request that is going towards 27.0.0.1 and forward that request to the ASA. ASA receives a request for 29,001. He will forward the request to the device over here. Similarly, for sales, let's say I want him to be able to tell it to R1. I would create a port forward, same name, a 29002, 10.11.11.23, or let's say do it to router 1. All right, so now the user would have the ability to telnet into 10.11.11.1. Once the redirector would be installed, it would sit over here. The Java redirector would be sitting. If the client telnet in to 10.11.11.1, it would not work. He would need to telnet into what? 127.0.0.1 for port number 29.0.0.2. On the Java redirector, it would show you that port number. So they would know exactly what port number they would need to telnet into. So it wouldn't be a, what do you call it? It wouldn't be something that they would need to find out. It would be on their screen. The Java redirector would automatically install, would automatically play on the screen of the client. So that's the bad part about this, is if you don't have the proper version of Java, it won't work. So once I create this port forward, which I did over here, the next thing is to apply it to the particular group. So I created it over here, and I'll group my group policy. Same place that I had done before. Go to the attributes. Under sales attributes, go to the web VPN attributes. In here, you can specify your port forward value as sales. So basically, I'm allowing this particular group to have port forwarding done based on sales, which gives him two different additional port numbers. So now when I go over here, back to my client, I log in as Cisco 123, continue. You'll notice there's a new option over here called the application access. When you click on it, it says start application access. As soon as you click on the start application access, it will open that Java redirector. The problem with that is you need to have the old version of Java. And on the window, you would see that 127.0.0.1 or 29.0.0.1 would redirect you to 10.11.11.19 or port 1521. That would tell the user, hey, listen, open your application to this particular port number. And it would also have the second one that I created. So you could see that over there. The user would see that over there. So if he wanted to do telnet, he would open his PuTTY. The address would be 127.0.0.1. Port number would not be 23, it would be port number 29.0.0.1. So that would be redirected to ASA. ASA would then in turn forward it towards the appropriate client. You guys okay with that? But in order to do that, I need to run this application. The only thing is I'm not sure if it's going to work or not, because I don't have the old version of Java installed. Even if I have tried to do it, it's going to install the new one, and Java in this particular version will not work. You understand? So once I install this, once I have the Java up, then it'll be there for it to do the redirection. This is the main reason for WebVPN, clientless WebVPN not being a success, is because of this reason. Let me put the notes for you guys in terms of doing it. How would I do the port forwarding over here? Configure the port forwarding for non-native applications. And that I did by going to WebVPN, creating the port forward first. Port forward sales, port number 29,001. redirect it towards 19, 15, 21 as an example. Port forward sales 10.11.11.1 port 23. You can do multiple ports. Let's say I also want to be able to SSH into something. Once you create it, then you apply it to your appropriate group that you want this to be done to. And under there, you do web VPN, and here you specify that this particular group should have port forward based on that's your third type of what you meant by native support. Native support is this support. Remember what I told you? These three are, you don't need any port forwarding. So if you had an internal FTP server, you could just type in the IP address of the FTP server and access it, or HTTP server inside access it. But I'm only limited to these four protocols natively. Any other protocol like Telnet or anything like that, I would need to do a port forward. What is the difference between clientless and RA AnyConnect VPN? On the AnyConnect VPN, you would need to install the client, the AnyConnect VPN client. I'll also show you that, but not today because I don't have that PC over here that has my AnyConnect on it. I'll show you that. The first thing that I'll do next time is show you the AnyConnect client. So this is remote access as well, but this is the clientless remote access. Good? And that is it for today. So next week, what we need to take a look at, let me bring this up. Is this the one? Yep. So right now, the only things that are left over from that is this portion, which doesn't take that long, configuring the global policy with MPF. We've done the site-to-site. We've done the clustering and span mode today. We've done the remote connect SSL VPN. I'm going to show you the AnyConnect now. We use AnyConnect with IP2. That's the only thing that's left over. Nothing on the client except for Java. You need to have Java installed. So next week, after we're done with this part, which should not take that long, we'll get into the FTD portion. So next week is FTD. So I should be done with the FTD next week. And the following week, we'll start the other stuff, which is ESA, WSA, wireless, and all. All right, we're on schedule to finish based on that schedule that I gave you guys. Let me save this talk. Today, I am not too sure about this. All right, guys. Next week, same time. Abid, I'll probably do it tomorrow because the connection over here, it's about a 1 meg up. It'll take forever to do. I'll try to do yesterday's today. And today's I'll probably do tomorrow from work. Make it about 20 minutes. I just want to grab something to eat and then we'll get started. All right, guys, you take care. See you next weekend. Good night.